Okay, we'll go into problem number 15 here. And in this problem we have the graph of function f consisting of these three line segments given in the picture there. And we're told that g of x is equal to the integral from 1 to x of f of t dt. So g of x is the area accumulating function starting from x equals 1 and sweeping to the right, or starting at x equals 1 and sweeping to the left. The first thing we're asked for is to find g of 4. And so g of 4 by definition is just the integral from 1 to 4 of f of t dt. So if we start at 1 and sweep to the right, we can kind of break this shape down into three geometric pieces. We have the trapezoid from 1 to 2, we have a triangle from 2 to 3, and another triangle below the x-axis from 3 to 4. In the trapezoidal piece there, the area of a trapezoid being h over 2, and here the height is just 1. The height is the perpendicular distance between the pair of parallel bases, so that's 1, and the first base is the height of 4, or is the point 1 comma 4, and the second base is 1, or a length of 1. So the trapezoidal area is about 5/2, or is 5/2. In the first little triangular section between 2 and 3, we have an area of 1/2 base height, and the base and the height are both 1 there, and 1/2 of 1 times 1 is a half. And you'll notice that the next triangular shape area that's below the x-axis is the same shape with the same dimensions, and it'll also be a half, except it'll be a negative a half. The integral will be a negative 1/2 because it's below the x-axis. So you should notice that the area between 2 and 3 and between 3 and 4 will zero each other out. So as we go from 1 to 4, the only thing we need to take into consideration is the trapezoidal area. And that's 5/2, so that's the first part of that answer. Now we want g of negative 2. Well, by definition, g of negative 2 would be the integral from 1 to negative 2 of f of t dt, but we're going in the wrong direction here. So we're going to use the properties of integrals to rewrite that as the negative of the integral from negative 2 to 1, since we always want to go from low to high. And so that area is going to be the area from negative 2 to 2 is a triangular shaped area with a base of 3 and a height of 4, and so that area will be 6. And because we're sweeping to the left, or from right to left, accumulating area from right to left, that integral will actually be negative. So that's the answer to part A. In part B, we want to find the instantaneous rate of change of g, which is g prime of x. And that's just the derivative of the integral from 1 to x of f of t dt by the fundamental theorem, that is just f of x. And so g prime of 1 will be f of 1, which is 4. Alright, now in part C, we're looking for the absolute minimum value from negative 2 to positive 4. And we want to justify our answer. So since we're looking for an absolute min, I'm going to invoke the extreme value theorem, which everyone knows states that a continuous function on a closed interval always has an absolute min and max. It will occur at critical values or endpoints. In this case, the critical values will be when g prime of x changes sign. Since g prime of x is f of x changes sign only at 3. So we know that the absolute min has to occur at one of these values. We already know that f of negative 2 is negative 6. We know that f of 4 is 5/2. f of 3, which is a relative max, will be 3. And so our absolute min occurs at negative 2, and the value is negative 6. Finally, we're told that the second derivative is not defined at 1 and 2, and how many of these x coordinates are points of inflection. Well, g will have points of inflection when g prime prime changes sign. We know g prime prime of x is f prime of x, and f prime of x, that is the slopes of f. And since the slopes of f change sign only at x equal 1, then that will be the only point of inflection for g on this interval. Okay, so that does it for this problem, and we'll go on to the next.